Finally, we discussed the use of empirical analysis and analysis by simulations in the evaluation of the performance of algorithms. There are times where the program you're trying to analyze is too complex or maybe too large that you cannot perform asymptotic analysis. Note that what we have discussed up to now was based on code segments mostly. When the program is too large, you cannot identify each and every part of the program and analyze separately. All you can do is you can estimate where the real problem could be and you only attack that part. But if the program, as I said, is too large or too complex, you might not be even able to identify these. Or maybe you don't have access to the algorithm or the code to analyze it. In such a case, what you can do is you can run the competitor codes and do this time measurements that I in the beginning said is not a good approach, but now you don't have any other option. So you have some competitor codes, alternative codes, and you run these, but this time under same scenarios so that you have a fair comparison and you obtain empiric data from these tests, experiments. And these are called benchmark tests. You might have heard the term benchmark test. For example, when you want to buy a computer, you can go on the internet to find benchmark tests to compare alternative computers or phones, whatever you're trying to find. Note that these benchmark tests might not be always fair, so you should be very careful while reading such reports for benchmark tests. So when you're working on empiric analysis, don't forget that, as I said, these tests could be quite subjective and the results could be quite debatable. The scenarios that are considered in this empirical analysis should not be favoring one over the other. I can easily cook scenarios which will show how good my software is compared to yours, and not show scenarios which actually favor your algorithms. So you should make sure that the scenarios are fair. Your scenarios, therefore, should be openly declared. You cannot say, this computer runs better than the other. You should say, I have set up such a scenario. These were the parameters for the scenario. This scenario corresponds to such a real-life example. And I have run all of these alternative programs or hardware, whatever you're testing, under these fair conditions according to this scenario. And these are, I also obtained the results. I took the measurements in this way, and here are the results, to make sure that you're not abusing the benchmark tests. But even if you define such scenarios, the producer of those softwares, if they know what scenarios you're running, they could tune their code to pass only your tests. That means in real life, it will not work accordingly. But if they know exactly all parameters of your scenarios, they could be tuning the performance of their code to pass your test. But in real life, it's not running that way. We have seen similar problems lately, for example, in the case of automobile vendors, where they tuned their engines to perform well under the scenarios that were used in the test, but in real life they were not running with the same performance. So beware of code tuning. To understand this, to understand whether the vendors have done code tuning or not, You can look at the performance ratios of two competitors under different input sizes. You take the same scenario, just play with the input size, and if you realize that the ratio of the performance of those two competitors is always constant, you can assume that one of the vendors at least has done parameter tuning or code tuning. In this case, try to play with the scenario and see if it matters or not. There are two approaches. What we discussed was empirical analysis. There's also the concept of analysis by simulations. We'll not go into the details of that because really it depends on what type of simulation you're running. But the analysis by simulation is utilized to execute the scenarios that will be difficult to test otherwise. That means you cannot create those scenarios by hand. They're impossible to create. For example, let's say you're trying to design a voting system and you expect on the day of the voting 10 million people to vote. Now, you cannot create such a scenario by hand. You cannot get 10 million people to help you in testing. And you have to do this testing before the day of the voting to see if the system will crash or not. So what you do in that case is you have simulated voters, which are actually code segments or pieces of programs running on the same or different computers, and creating data packets as if those packets are coming from real voters. Now, this is a simulation of the voting, and this kind of analysis is called analysis by simulation. So again, we're talking about a scenario which is difficult or sometimes impossible to create by hand. Okay, so this is analysis by simulation, which is different from empirical analysis, in which you really do real tests. Like you take a computer and start running 10 programs, 10 specific programs on it at the same time, and you measure the performance. In this case, there is no simulation. You're really doing those tests. And that one is called the empirical analysis. That is the difference between empirical analysis and analysis by simulation. And thus, we reach the end of this chapter. Have a nice day.